So what happens is actually maybe we need better coordinates. Why do we need better coordinates? That's because the geometry is kind of difficult to do if you use xy coordinates. I mean, formula for cross product is fine, but then the length of a vector will be annoying and it just doesn't look good. So instead, let's think about it differently. Oh, I have one more board. Okay, so I claim if we do it this way, and we express then the area as a function of xy, well, actually we can't solve the minimum for the minimum. So here's another way to do it. Well, what's worked pretty well for us so far is this geometric idea of, base times height. So let's think in terms of the heights of these side triangles. Okay, so I'm going to use the heights of these things. And I'm going to say that the area will be the sum of three terms, which are three bases times three heights. So let's give names to these quantities. So actually for that, it's going to be good to have the point in the xy plane that lives directly below P. Let's call Q. So P is the point at coordinates x, y, and h. And let's call Q the point that's just below it. So it coordinates x, y, 0. Okay? So let's see. Let me draw a picture, actually. Let me draw a map, of this thing, seen from above. So you have P1, P2, P3. I have my point Q in the middle. So let's see. To know these areas, I need to know the base. Well, the base, I can decide that I know it because it's part of my given data, right? I know the sides of this triangle. Let me call the lengths A2, A1, A2, A3. I also need to know the height, so I need to know these lengths. How do I know these lengths? Well, it's a distance in space that's a little bit annoying, but maybe I can reduce it to a distance in the plane by looking instead at this distance here. Okay? So let me give names to the distances from Q to the sides. Okay, so let's call U1, U2, and U3 the distances from Q to the sides. Well, now I claim I can find, actually, sorry, I need to draw one more thing. I claim I have a nice formula for the area because this side here, so this is vertical and that's horizontal. So this length here is U3, this length here is H. So what's this length here? Yeah, it's square root of U3 squared, oops, plus H squared. And similarly for these other guys, they're square roots of a U squared plus a H squared. Okay? So the heights of the faces are square root of U1 squared plus H squared, and similarly with U2 and U3. So the total side area is going to be, well, area of the first face is 1/2 of base times height plus 1/2 of over base times over height plus 1/2 of third one. doesn't look so much better, but trust me, it will get better. Okay, so now that's a function of free variables, u1, u2, u3. And how do we relate u1, u2, u3 to each other? They're probably not independent. Well, let's cut this triangle here into 3 pieces, like that. Oops. Then each piece has side, well, let's look at, say, the piece at the bottom. It has base A3, height U3. So cut the base into 3 tells you that the area of the base is 1/2 of A1 U1 plus 1/2 of A2 U2 plus 1/2 of A3 U3. And that's our constraint. Okay? So my 3 variables U1, U2, U3 are constrained in this way. The sum of these 3 guys must be the area of a base, and I want to minimize that guy. So that's my G. Okay, and that guy here is my F. So now if I write the Lagrange multiplier equations, well, partial F over partial U1 is, well, if you do the calculation, you will see it's 1/2 A1 U1 over square root of U1 square plus H square should be lambda times what's partial G partial U1. That one you can do, I'm sure. It's 1/2 A1. Oh, these guys simplify. Okay, if you do the same with the second one, things simplify again. And same with the third one. Well, you will get, after simplifying, U3 over square root of U3 squared plus H squared equals lambda. So now that means this guy equals this guy equals this guy. They're all equal to lambda. And if you think about it, that means that U1 equals U2 equals U3. See, it looked like scary equations, but the solution is very simple. So what does it mean? It means that our point Q should be equidistant from all 3 sides. That's called the in-center. So Q should be the in-center. So the next time that you have to build a golden pyramid and don't want to go broke, well, you know where to put the top. Okay, if that was a bit fast, sorry. Anyway, it's not completely crucial, but, you know, go over it, you will see it works. Have a nice weekend.